Okay, we should start. Welcome everyone to the ROLL meeting. ROLL stands for Routing over Low Power and Lossy Networks. And consider this session is recorded and posted into YouTube. And we have our chairs, Dominic, that is joining us remotely, and myself, Secretary
Hello.
Michael Richardson. And yes, okay. Please be aware that this meeting for the newcomers is aligned with the Not Well. So we just have to consider that we treat us respectfully, and please, we ask as well that you read it carefully. And first of all, thank you very much, Alvaro, for all this year of amazing work. It was a pleasure to have you here.
Hi, Alvaro Tarravidi. Thank you. And I've been very happy with this working group for being responsible for so many years. And I say being responsible, but in reality, I've been very happy because all of you have done such a great job. It is, and I tell this to everyone, including John, who's the new AD. This is one of the best managed working groups that I've seen in at least in the routing area. And I think the way that you, Ines, and Dominica's chairs have managed to get the working group working, and the interaction that the participants have is great. Is a really good example of how I think a working group should be run. So thank you for all the great work, and welcome to John.
Welcome, John.
Yeah, thank you so
very
much. It was a
Alvaro.
pleasure working with you. You've been a great AD, and I've really enjoyed your contributions. And thank you again, Alvaro.
Okay, thank you very much. So, meeting tips, please wear your mask. You can take the mask out for speaking at the microphone. Make sure to sign into Miteco, and if you want to speak, please join the queue. And if you are remotely, please make sure that your audio and video are off, unless you are, of course, talking. And then, well, these are the links to the resources for the material, and as well for ROLL. We would like to know if we have minutes takers that can help us with the notes. Do we have volunteers?
We need volunteers. Right now, there's only myself connected.
Someone want to help us with the notes?
Okay, I see somebody else joining. Right now, anonymous. You need to,
okay.
In order to be able to edit the notes, you need to log in for the data tracker.
Okay. So we have one more person into the notes. That's good. Should we advance? Okay. This is our agenda. We are going to give an introduction of the working group status, and then we are going to go briefly about the active internet draft that we have at the working group. So we start with ODB REPL, and then DAO projection, and then NCA extension, RNFD, and finally with MOPEX, and then open floor. Some comments about the agenda? Okay. For the draft status, Common Ancestor Objective Function, NSA extension, went back to the working group. We are going to discuss about this today. Then ODB REPL is in working group last call. We are going to discuss about the status of this draft today. And as well for DAO projection will be discussed today. Enrollment priority is expired momentarily, but the open issues are being addressed by Michael. So it's in progress. And about MOPEX, mode of operation extension, we are going to discuss about that today. REPL capabilities, it's in the queue for waiting for attention. And then fast border road crash detections. We will discuss that today, and it's the last work adopted by the working group. And then REPL role storing road acknowledge. Yeah, we needed to decide if it's ready for working group adoption.
Okay, so ahead of us,
About
we
the
have the milestones of initial submission of DAO projection. That was due like 10 months ago, but we know we're working on it. We're making progress, so we're a bit late, but the situation is progressing. We had the MOPEX and enrollment priority draft to be submitted in the fall. Hopefully we'll catch up and have that submitted within the next 6 months. So we believe it's under control. And I've also highlighted the milestones that we ticked as done, which were initial submission of NSA extension and initial submission of EODV REPL to the ISG, and they were ticked as done because we had initially submitted them. But then, especially for lack of reaction time and Alvaro leaving the position and John coming in as a new AD, the documents were returned to the working group, and we are going to initiate this submission again. So, yeah, we have submitted them initially. So the milestone is ticked that has done, but we still have that same work ahead of us, hopefully, and we're going to explain that during this meeting. Hopefully, this will happen pretty soon in the coming weeks or months. Thanks. That's it for me.
Thank you very much, Dominique. Okay, we continue with ODB REPL. Charlie, are you there? We saw you at the beginning. Here. You should be able to speak. Okay. Okay, Charlie went offline, so we wait a bit until he logs in again.
Okay, I think you can go ahead, Ines, since the first slides were yours anyway.
Yeah. Okay, an introduction of ODB REPL, supporting asymmetric leaks in low-power networks. This document presents a reactive peer-to-peer route discovery for hop by hop and source routing. The routes are set on demand from origin node to the destination target node, and thus we enable the discovery of 2 different routes. From origin node to target node is one, and the other one is from target node to origin node. And for that, for the route discovery, first it's form a DAG, route at the origin node. And then we have 2 instances here. The route request instance that is formed by control messages from origin node to target node to be able to send messages from target node to origin node. And then we form another instance through route control messages from origin node to target node to be able to send messages from target node to origin node to be able to send data from origin node to target node.
You hear me now?
Yes.
Okay, well, I was getting message unstable connection to server trying to recover, but then I just exited and came back in.
Okay. No problem. Do you want to say something about this slide or?
So, well, I can talk about the slides. Do you want me to make the presentation or do you want to keep on?
You just tell me and I can advance. Do you want me to go to the next slide?
So, okay, if you've already discussed this, I mean, this is just a summary slide to just tell you how AODV Ripple works. We can go to the next slide if you like. It seems to be quite slow. Sorry, I'm not seeing the slide yet.
You're waiting for the slide to advance?
I think it's not displayed in his screen. Are you in presentation? In the presentation view, in the first button of the upper. If you click on presentation view,
I have the presentation here also. Okay, so now it's visible.
Okay.
So AODV Ripple depends on having the three options. One is to request a route. Another one is to make a reply to the route request. And then the third option supplies the desired destination for the route. And it does this by essentially trying to deliver the route request to every node that might have a route to the destination, and it uses a multicast address for that purpose. Mode of operation is 4, and it does not interfere with P2P Ripple, which was RFC 6997. So they operate independently. Next slide.
Maybe if you, okay, next slide is there. It's about the versions.
The presentation here in front of me, even though I don't see it in the Meet Echo. So we had numerous comments come in, and then the version 16 was published in February to address those comments, and it was quite a few of them were readability issues, and there was some protocol clarifications that were required and some improvements. Also, Pascal and Conrad made reviews, extensive reviews actually, and so we were able to resolve the comments that were made. In particular, Pascal had some comments about how AODV Ripple, when it should be preferred or not preferred compared to other protocols developed within the Roll Working Group. And so we made some details about that and supplied citations for work that had been done to support that. So that was some of the changes to go from version 15 to version 16. Also, it's just one thing that was emphasized here is that one of the advantages of AODV Ripple is that it can provide shorter routes that don't have to go through the root node. And so that means that it can provide better performance. And not only that, but if all the routes in the network go through the root, then it can induce congestion at the root. So that's not necessarily desirable. And also we clarified that if your same device or same node has multiple interfaces that are routing, they are treated independently. We don't do any sort of binding between the independent interfaces. And the point that has come up several times is if you have a choice between a symmetric route versus an asymmetric route, you might intuitively think that you would pick the symmetric route because it involves fewer devices, but it's not necessarily true, especially if the asymmetric route provides a better rank function for the objective function, better rank evaluation for the objective function. So next slide, please.
Okay, next slide there about the directorate reviews.
Yeah. So this when we had the comments from the various people, it was actually sent back from the IESG to the working group, and then after resolving the comments, another working group last call was relatively recently concluded, and I don't think we got particularly comments from the working group last call, but what we did get was a review from Tony, and so that have been so those comments from Tony were quite interesting, many of them, and had to figure out exactly how best to resolve them. And so another revision, draft number 17, will be done, well, hopefully tomorrow, but certainly in the next day or two. And I will also send out to the mailing list some discussion about the observations and comments that were made on the Tony's route directory review. So among the things that were requested was to actually be more explicit about and insert more terminology items. And also there's an important operation in AODV Ripple. It's important for the originating node to be able to identify which of possibly several outstanding route requests. It needs to be able to identify which of them are satisfied by a route reply that is received by originating node. And in order to do that, we use Ripple instance ID, and there, because of the way Ripple works, it is possible that the instance ID cannot be used exactly the same between the route request and the route reply. And when that happens, which is not, it's a rare case, but it can happen. And when it does happen, that we have to have a method for associating the route reply to the proper route request, and that is done as described in the draft. But the language that we used for that has not always been perfectly well understood, so we try to make it more clear so there's less chance for ambiguity. And so that we are doing that, or have done it actually, but the next draft is not out yet. And then one of the sort of basic things, but it needs to be emphasized, is that if you have a choice of multiple routes, you have to take the one with the most recent sequence number, because the point of the sequence number is to exactly protect against using information that, for whatever reason, was delayed and not delivered for a long time. So I guess that's about it.
Thank you very much, Charlie. We have a
Yeah.
next step slide. Basically, that after the routing directory review that is addressed, I think we can submit to the ISG. Do you have some comments for Charlie? Question? No? So,
Well,
okay.
my email box is always open, and I really try to be responsive. So if anybody thinks of something tomorrow or next week, no worries. Please send email.
Okay, great. Thank you very much, Charlie. We are waiting
All
for
right.
the new version. Looking forward for the
Yeah,
new version.
I'll try to have it tomorrow. Also, not related to anything, but I just wanted to say this is the very first time I ever made a remote presentation at IETF. So interesting, and the tool seems to be quite good. Thank you.
Yeah, it's great. Thank you very much. Okay. Thank you, Charlie. And thank you for joining us so late there. I know. Okay. Next presentations is our projection. So, what is the goal of the DAO projections? That the root can install and maintain projected routes within the DODA in a chosen durations. And these specifications expect that the mode of operation of the network is non-story mode. So the root notes the whole topology, basically the relationship parents and children's. And now with these specifications, we augment the capability of the root to include the information of the siblings. So the root can inform to the PCE path computation element, and the path computation element can build better routes to traverse the siblings. And this specification particularly extends RFC 6550, 6553, and 8138. So how this specification extends RFC 6550, which is the goal of that? Well, enable the transfer routes from east to west, and when the DODAC is operated in non-story mode. So for that, several features and items has been created for this draft. So we start for the projected DAO message. That is route route by the route that indicate the track ingress. Basically, the projected DAO message state indicate all the routes, the P route that has to go from the track ingress to the track egress to form a track segment in story mode or a track lane in non-story mode. Then, of course, we have the projected DAO acknowledge that the destination node issues. And then we have as well the via information option, basically that contain the steps, the route. So this via information option extend the control method options and create a new via information options. And then we have two modes. A story mode via information option that install a strict hop by hop P route to form a track segment, or the non-story mode version that install a loose source route P route that is called track lane. Then this specification as well extend the control method option to create the sibling information options to track information of the siblings. Then as well, to be able to trigger the projected DAO message, we need to first request it. So for that, we have two control messages that is extend the Ripple control messages set. And this projected DAO request can be triggered by any Ripple aware node to request the establishment of a track between itself or another node that is a track egress. And then the node request to the root, and then the root confirm with the acknowledge. And as well, this specification amend the RPI, the REPL option, basically to create a flag. And this REPL option is the routing information that travel in data planes packets. And this flag is called projected route P. Basically, is a one if the RPA is added into the basically this flag is added into the encapsulation of the RPI when travel through the route of the P route, and is zero when the packet travel in the DODAC, not into the projected route. And as well, we indicate as well, we extend the add additional flags to the REPL DODAC configuration option to indicate that we support this specification. So it's one when the network support DAO projection, and it's zero when it's not supported, basically for legacy implementations. Well, as was mentioned previously, this draft as well extends RFC 5553 in order with the flag to indicate that the REPL option is travel through the projected route, the data packet of the that contains the REPL option. Then as well, this draft extends the RFC 8138, basically to indicate encryptation. And for that, this specification introduced a new 6-low pan routing header, PRPI 6-low RH. Basically, that is designed to compress the RPA, the REPL option, that travel through the projected routes. So basically, that is the extent that this draft includes. So the working group last call passed months ago. Now, I mean, we was submitted to the ISG and was returned because some review of the routing directorate and security directorate was missing, and some small fix as well. So there is no open items now. But we have a bit of delay to get the review of the routing directorate. So it was stuck for some weeks, but now we think that we can have it ready in the following 2-3 weeks. So the next steps will be submission to the ISG as soon as we have the review of the routing directorate. Some comments? Pascal, are you there if you want to comment something?
I'm here, but you said it all. I mean, we are done with this document.
Yes. Okay.
And
thank you
yes,
very much.
We'll be addressing the routing directorate review
Yes.
comments when we get them.
Yeah. Thank you. Some further comment or questions? Okay. Thank you. So NSA extension. Dominic?
Yep, coming up. Hi again. So this draft has had a long story already. It was submitted for publication to the ISG in 2021 in March. It seems something major is happening on this draft every March. We got an AD review by Alvaro, and then because of the a change in position of the main authors, they were quite long addressing the review and providing responses and changes. And so eventually, as I already said, Alvaro leaving the position and no improvement on the draft being provided, the draft was returned to the working group, and now it shows up as expired and dead state for the ISG, but nothing wrong with that. So we engaged the authors, tried to understand if they were willing and had the resources to push this to publication. And Aris, one of the authors, said yes, he feels he actually commits on being able to work on that. And push it all the way through. Giorgio said he has very limited availability, and Pascal didn't feel he was a lead author, is willing to help as well. So we're glad to have Aris really back on the workbench for that. Oops, can I get the control? Just ask. Yeah, good. Good,
Yes,
thank you.
I just came.
So what is this draft about? The idea is that the nodes in a Ripple mesh will be able to select parents, alternate parents, because we're multiple parents, will be able to select alternate parents based on some information that was not available with the legacy version of Ripple, which is what grandparents are connected to those parent candidates. And so in the drawing, which is extracted from the draft, you have a node C that has, the node S at the bottom that has C as a preferred parent and is wondering if it should add A, B, or D as secondary parents. And the technology that's specified in this draft will help us make a decision by having A, B, and D provide information, A, B, C, and D actually provide information on exactly who their parents, their own parents are. So the grandparents at the top, W, X, Y, Z. And so S can make an informed decision on whether to prefer A, B, C, D as alternate parents. And why would you want to do that? Well, you might want to have a secondary parent because Ripple allows to do forwarding on the secondary parent without redoing the routing side of things, or you might want actually to replicate your packets and do PRE, packet replication and elimination, but you don't want to flood the networks and packets everywhere in the networks. You would want to send them along paths going up that are going side by side and take advantage of overhearing. So it might not cost you actually anything to send to both parents because of the overhearing. So that's the idea, controlling your paths to be parallel or have interconnection through the grandparents. So for that, we need two things. One is you need to be able to advertise who your own parents are to your potential children. And the other thing is we need an objective function that provides the algorithm for selecting the appropriate parent based on that information. So that's the idea. So this draft introduces a new piece of information that goes into the DAG metric container, which is used to contain the metrics and constraints for routing. And it was selected to use a TLV, which is actually the list of IPv6 addresses of a router's parents. So that's shown at the top, and at the bottom of this slides, we describe how the objective function was specified, and it actually reuses the text of an existing objective function called Mr. Hoff 6710 by saying take that text and amend the text with the following deltas, and that's a new objective function. So we're not technically modifying 6710, we're just reusing the text of 6710 to build this new objective function. And actually, the draft describes 3 different policies. I kept vague on exactly how you select the parents based on the grandparents' information. That was on purpose because there are different ways of selecting that, making having your paths open a bit wider or being stricter, a bit narrower, and that choice is left up to the node that could be configured to use one policy or another based on maybe situation in a DODAG or any other reason. In terms of implementation, the authors have an implementation on Contiki in one of their private branches. There's a Wireshark dissector for it. It was tested on a simulator. I'm not sure about the publication of the results in an academic paper, but at least we have material to show that this works. So we got the review by Alvaro. He had one major question, which is, okay, PRE, packet replication and emulation is mentioned as the main goal, main reason for wanting that technology, but could it not be used for something else? And the draft maybe should not center on the use case on PRE. And so can you think of other use cases for that technology? And then a list of detailed comments on the draft, which I could not copy all the way, all here in the slides, but you have a flavor for those comments. You know, just taking one, the last one here, you wrote should. Why is it a should? If you don't do what it is mentioned, what happens, etc., etc. So all good questions to make the specification more accurate, more complete, etc. So the draft returned to the working group. Aris committed on working on it. So we believe we first want to address the comments by Alvaro because this makes the draft obviously much better. So this is our internal goal here. And then when this is done, then we'll go through working group last call, etc. The whole process. But we feel confident that there is workforce, there's interest, and we have a solid material to build on. And that's it for this one. Any questions, comments? Pascal?
Yes, Pascal?
Yes, you explained very well, Dominique. Thank you so much. What the idea is in this document, in this draft. The initial name that we gave to the idea was DNA, like a DNA chain. And I like the image because it really shows what you're trying to build. Instead of having a line which can be broken, we are having this chain of common grandparents, like two parallel things which are rolled one into another. So you can always cross, from one line to the other if it breaks going up. That's the idea, making the path from the final child all the way to the root a lot more resilient by having this double helix, if you like, twinned together through common grandparents. That's what's behind this draft. If you want a very, very short idea of what's going on with this draft. All the rest is how you build it.
Yep, thank you.
So.
Questions, comments? Okay. So that was the plan for this one. I'm going to carry on with RNFD. So this is a more recent piece of work that was initiated by Conrad. Is Conrad online? I haven't seen him. No, it isn't. So this work was adopted last year by the working group saying, yes, there's definitely interest. Conrad came with a pretty well defined, conceived ID protocol. He had performance studies done by his students and colleagues in Warsaw. And so we're only getting the resources in the working group to seriously work on this, I think. So he and his team did most of the work. We had an interim meeting last June where we discussed the draft. We took the time to go in depth. There were some question asks during the interim, and then it took quite a while for Conrad to respond. He was busy with something else at work, and so he published a response in October, trying to summarize the questions and his answers to the questions. But that was shortly before London. We were busy with the other drafts, and so that mail, I think, was left unanswered and died on among all mails on the mailing list. So I think it's time to revive that and push it to the conclusion. So we have an algorithm, we have a protocol. We need to make sure we have a consensus that this is good technology. This is a way we want to address the problem. Everybody agreed that there was a problem to be addressed. That's what when we adopted the document by the working group. Now we need to make a decision on the technology to solve that problem. So that's in one slide, and I'm going to give you a little bit of background on that, not trying to get too deep into the algorithm, especially the consensus algorithm that's a bit involved. You can read the draft, it's very well written, but just to give you a flavor of what's going on, we have some DAG roots neighbors, not necessarily all of them, but a subset of them that take a new role called sentinels in terms of monitoring the state of the root. So Ripple isn't changed, it goes like normal, but we have this extra function of the some one hop neighbors of the root to be sentinels. And so they are chartered for having an opinion on whether the DAG root is up or down. And the opinion is gradual, and they can be certain that the root is up. They can have doubts, suspected down. They can have a firm belief that the root is down, locally down. And then they can be in a state where they believe the root is down, and a majority of nodes around them believe the same. And so they get to the state that they believe the root, they know the root is down. And there's nothing you can do when everybody agrees the root is down. The only way to join the DODAG again is by the root rebooting and issuing a new instance number, proving it's up again. The other nodes, which are not the sentinels, trust the opinion of the sentinels. They don't have an opinion on their own about the state of the root, but they just count how many sentinels believe the root is up or down. And if the number is above a given threshold, that's a constant, a parameter in the protocol, then we stop operating on this instance. All nodes, all routers remove all of their parents and advertise an infinite rank, so they don't try to route and they don't lure any of the nodes into routing through them towards the root. And so the way it is consensus, distributed consensus is achieved is through CFRCs, conflict-free replicated counters, which are distributed in the routing information option called DIO. So technically what the draft specifies is a new DIO option that propagates those counters. And the propagation, the dissemination is controlled through a trickle timer. It's recommended to use a separate trickle timer than the way used for the routing metrics, but it could, as a fallback position, it could be the same one, but that would tie the two protocols a bit more than we want. And so the draft specifies exactly the operation on these magic counters, the thresholds, and everything. So here's a summary of the June interim. Questions that were raised were what happens when sentinels don't hear one another. It may look like they talk between them and they reach a consensus and then they propagate their consensus to the other nodes. So how does that work if the sentinels don't hear one another? And Conrad's answer, I'm reading his email, I copied his email, I'm reading here, was that it's not the sentinels that makes a final decision. They each have an opinion, and the consensus is evaluated at each node through merging of those counter information that are being propagated through the DIOs. And so if there's any connectivity between the various branches down the DUDAG, the information will propagate down and up again, and everybody, the whole network will eventually agree that the route is down. So there's no need to have direct communication between sentinels. So a hub and spoke model is a bit different, but if there's any mesh, we'll have an agreement on the whole network. Question 2 that came out of the meeting. What if the sentinels lose connectivity to the route, but the route in fact is still alive? So the sentinels will think the route is dead. It's not dead, it's just they lost connectivity. They all lost connectivity to it, or most of them lost connectivity to it. And so aren't we going to diagnose a route failure and the route actually is still alive? So yes, the answer is true. The sentinels will think the route is dead, but since you've lost so much connectivity at the top of the DUDAG connecting to the route, then it's probably a good idea to start a new instance and reshuffle, reorganize your mesh anyway. And so diagnosing that the route is dead will mean that the sentinels will force the DAG route who's monitoring those counters to issue a new instance number, and that will trigger a full rebuild from a blank sheet of paper of the DUDAG, which presumably by Conrad is a good idea anyway. So it is maybe an improper detection by the sentinels, but the reaction is still good and appropriate. So there are 4 of those questions. I'm reading them, and maybe we can have the discussion after that. Oh, and I just said that, by the way, the DUDAG will be rebuilt. Is that desirable? Yes, it's desirable, because there was such a radical change in the connectivity anyway, that you would want to rebuild the DUDAG. And that was a question, I think, by Pascal, if I remember correctly. You're trying to have the sentinels guess the state of the route and then have a consensus within the mesh about the state of the route. If you have a doubt, why don't you ask the route itself if it's dead? And if it doesn't answer, you know it's dead. And Conrad's answer was that actually you do ask, the sentinels do ask the route. I mentioned the soft states suspected down when the sentinel has a doubt about the state of the route. It is actually written in a draft that the sentinel may confirm that doubt or check on the route by asking directly, or use any other information available at layer 2 or layer 3 to make a decision on that. So the protocol is meant to work even if the sentinels don't want or can't ask the route, but asking the route is not out of the question. It's actually can be used to improve the behavior of the same protocol. So that's, oh yeah, I wanted to have a slide on implementation. So there's one implementation by Conrad's team, and I'm not sure if it's publicly available, but since it's work in the academia, I'm pretty sure it is. So that's my last slide. As I said to begin with, do we think the current solution is adequate? I think the last discussion we had was about this. Can't we do better by asking the root? And we got Conrad's answer, which I explained previously. So Pascal, can we have your opinion on this? Are you convinced that this is good? Do you think we can make it better? Or do we have a consensus on the technology and then go for working group last call, etc.? Yeah, Pascal, I see raising hand.
Yes, Pascal.
Yes,
Yes,
if
you were
you
asking
agree.
me directly, right? I mean, well, only the questions that were raised were answered, and to my best knowledge, there was no better solution proposed. So we could go, in my view, we could go to workgroup last call, or we could ask for a last bunch of ideas to the group. For instance, if you want to secure the root, there are two things you want to do. One of them is to do something like what is discussed in this draft. The other thing is to double the root. And in our products, we effectively sometimes think about doubling the roots. And if you double the roots, then not only do you want to discover that the connectivity to one root is lost or seems to be mostly lost, but you also want to assert that the connectivity to the second root is better. And then toggle basically in the protocol from root 1 to root 2. I mean, that's a hot standby type of thinking. And so say the group wants to take this hot standby approach. Is this draft sufficient? Would we do yet another RFC just to do the toggle now? Or should we think about, improving a little bit the capabilities of this draft? I mean, not challenging that it works. It seems to be like the way to go. Now, is it enough meat for an RFC, or do we want to have a complete story? In which case, we would have more features in this document and before we go out.
Okay.
I think the question is more like that.
Point taken. I think in summary, how does it work in a situation where you want to do hot standby for a second route?
Do we have the full story? Do we still need proprietary functionality on top of this draft to actuate the hot standby and back? Obviously, when you do a standby, it means you have a backup route, but when the connectivity to the main route comes back, you want to toggle back to the main route. So it's this whole story that you would like to build.
Would you have time to allocate to work on that if we had that on one of the upcoming interims, for example?
I can discuss the issue. Should I work on this
by
document?
working, I meant just being present at the interim and engaging in the discussion. Okay.
Engaging the discussion always. Yes, sure.
Yeah,
doing
totally.
the work, I think it's Conrad's document.
I meant just the intellectual discussion, throwing the ball back. Okay, very good. So we'll put this draft on the agenda for the next interim, make sure we understand how this works in the situation you just described. And then when we feel confident about this, we'll issue the working group last call. Thank you. Ines, do you want to speak to the last slide deck?
Yes.
Oops.
Next.
Sorry, I think I made the mistake. I clicked the wrong button.
No problem. Okay. Sure. Okay, wait. Okay, we go to the end. Okay, for mode of operation, MOPEX. So we have a triple mode of operation. That means that the minimal specification that the network has to fulfill to be identified as a, for example, mode of operation, story mode or non-story mode. So for the mode of operation, we have 3 bits value, but this already exhausted. So to allocate more mode of operations, we are going to extend it. And for that, we are going to assign the value 7 to the mode of operation extension. So this is like a very short document that define basically this value 7. And this was in the working group for a while. At the beginning, it was together with the capability draft, but then get separated so we can expedite it. And then in the status, we believe that the draft is ready for working group last call. Still things are needed to be done, like the routine directory review and the security review, and as well the Shepherd document. After that, we believe that we can submit to the ISG. So, and as well, we would like to know if some volunteers would like to review this document. Very short document. Okay, Alvaro, thank you very much. Thank you very much. So, yeah, further comment or questions? Okay, so that will be entered to the queue. So in the queue, we have AuDB Ripple, DAO projection. This is our first that we have to handle. Then NSA, RNFT, and MOPEX follow. Yeah. So that was for mode of operation extension. Other business? Open floor? Okay, so after this work, I think we can start for the Ripple bis or version 2. Dominic, do you want to say something?
Nothing else than what we've said already.
Okay. Great. So thank you very much, everyone, and hope to see you in the next IETF.
Thank you.
Thank you.
Have a great day.
Have a great day.
Bye-bye.
Bye-bye. Join the meeting.